when the opportunity came to come to Tesla, that's something I'm just like incredibly excited to do, which is specifically take the amazing things that are happening both in the hardware side and the computer vision and AI side, and actually package that together with all the planning, the controls, the testing, the kernel patching of the operating system, all of our continuous integration, our simulation, and actually build that into a product we get onto people's cars in production today.
All these things, I said we would do them, we did it. I said we'd do it, we did it. We're going to do the robotaxi thing too. Only criticism, and it's a fair one, and sometimes I'm not on time. I mean, Audi's having major problems manufacturing e-tron, and they are extremely good at manufacturing. And if they're having problems, what about others? It'll be like owning a horse in 3 years. I mean, fine if you want to own a horse, but you should go into it with that expectation. If you buy a car that does not have the hardware necessary for full self-driving, it's like buying a horse. And the only car that has the hardware necessary for full self-driving is a Tesla.
Tesla Throwback Thursday. We've got part 3 of Tesla's first Autonomy Day, wrapping up this pivotal moment in Tesla's history. Without further ado, let's get to it.
All right, so that's actually from a clip of a longer than 30-minute uninterrupted drive with no interventions, navigating autopilot on the highway system, which is in production today on hundreds of thousands of cars. So I'm Stuart, and I'm here to talk about how we build some of these systems at scale. Just like a really short introduction on kind of where I'm coming from, what I do. So I've been in a couple companies or less. I've been writing software professionally for about 12 years. The thing that excites me most and I'm really passionate about is taking the cutting edge of machine learning and actually connecting that with customers through robustness and scale. So at Facebook, I worked initially inside of our ads infrastructure to build some of the machine learning, some really, really smart people. And we actually tried to build that into a single platform that we could then scale to all the other aspects of the business, from how we rank the news feed, to how we deliver search results, to how we make every recommendation across the platform. And that became the Applied Machine Learning Group. That's something I'm just incredibly proud of. And a lot of that wasn't just the core algorithms and the really important improvements that happen there, those that matters. A lot of it's actually the engineering practices to build these systems at scale. And the same thing was true at Snap, where I went, where we were really, really excited to sort of actually help to monetize this product. But the hardest part, we were using Google at the time, and they were effectively, running us on a fairly small scale. And we wanted to build that same infrastructure. We take our understanding of these users, connect that with cutting-edge machine learning, build that at massive scale, and handle billions and then trillions of both predictions and auctions every day in a way which is really robust. And so when the opportunity came to come to Tesla, that's something I'm just like incredibly excited to do, which is specifically take the amazing things that are happening both in the hardware side and the computer vision and AI side, and actually package that together with all the planning, the controls, the testing, the kernel patching of the operating system, all of our continuous integration, our simulation, and actually build that into a product we get onto people's cars in production today.
I don't know who this guy is, but color me impressed. That's what I love most about Tesla, is that the talent runs deep. Elon may be the face of the flagship of what we call Tesla, but eagles soar with other eagles. Winners associate with winners.
70 million miles already for Navigate on autopilot is something we're like really, really cool. And I think one thing that is worth kind of calling out on this is that we're continuing to accelerate and keep learning from this data. Like Andre talked about this data engine, as this accelerates up, we actually do make more and more assertive lane changes. We are learning from these cases where people intervene, either because they failed to detect a merge correctly or because they wanted the car to be a little more peppy in different environments, and we just want to keep making that progress. So to start all of this, we begin with trying to understand the world around us. And we talked about the different sensors in the vehicle, but I want to dig in a little bit more here. We have 8 cameras, but then we also have additionally 12 ultrasonic sensors, or radar, an inertial measurement unit, GPS. And then one thing we forget about is we also have the pedal and steering actions. So not only can we look at what's happening around the vehicle, we can look at how humans chose to interact with that environment. And so I'll talk to this clip right now. This basically is showing what's happening today in the car, and we're continuing to push this forward. So we start with a single neural network. We see the detections around it. We then build all that together with multiple neural networks and multiple detections. We bring in the other sensors, and we convert that into what Elon calls a vector space, an understanding of the world around us. And this is something where, as we continue to get better and better at this, we're moving more and more of this logic into the neural networks themselves. And the obvious end game here is that the neural network looks across all the cars, brings in all the information together, and just ultimately outputs a source of truth for the world around us. And this is actually not like an artist rendering in many senses. This is actually the output of one of the debugging tools that we use on the team every day. to understand what the world looks like around us. So another thing that I think is really, really exciting to me, I think when I do hear about sensors like LiDAR, a common question is around just having extra sensor modalities. Like, why not have some redundancy on the vehicle? And I want to dig in on one thing that's is not always obvious with neural networks themselves. So we have a neural network running on our, say, wide fisheye camera. That neural network is not making one prediction about the world. It's making many separate predictions, some of which actually audit each other. So as a real example, we have the ability to detect a pedestrian. That's something we train very, very carefully on and put a lot of work into. But we also have the ability to detect obstacles in the roadway. And a pedestrian is an obstacle. And it's shown differently to the neural network. It says, oh, there's a thing I can't drive through. And these together combine to give us an increased sense of what we can and can't do in front of the vehicle and how to plan for that. We then do this across multiple cameras because we have overlapping fields of view in many places around the vehicle. In front, we have a particularly large number of overlapping fields of view. Lastly, we can combine that with things like the radar and the ultrasonics to build these extremely precise understandings of what's happening in front of the car. We can use that both to learn future behaviors that are very accurate, but we can also build very accurate predictions of how things will continue to happen in front of us. So one example I think is really exciting is we can actually look at bicyclists and people and not just ask, where are you now, but where are you going? And this is actually the heart of what we're doing for our next generation automatic emergency braking system, which will not just stop for people in your path, but it'll stop for people who are going to be in your path. And that's running in shadow mode right now. We'll go out to the fleet this quarter, and I'll talk about shadow mode in a second. So when you want to start a feature like this for navigating on autopilot on the highway system, you can start by learning from data, and you can just look at how humans do things today. What is their assertiveness profile? How do they change lanes? What causes them to either abort or change their maneuvers? And you can see things that are not immediately obvious, like, oh yeah, simultaneous merging is rare, but very complicated and very important. And you can start to build opinions about different scenarios, such as a fast overtaking vehicle. So this is what we do when we initially have some algorithms we want to try out. We can put them on the fleet, and we can see what they would have done in a real-world scenario, such as this car that's overtaking us very quickly. And this is taken from our actual simulation environment, showing different paths that we have considered taking and how those overlay on the real-world behavior of a user. When you get those algorithms tuned up and you feel good about them, specifically, and this is really taking that output of the neural network, putting it in that vector space, and building and tuning these parameters on top of it, ultimately a thing that we can do through more and more machine learning, you go into a controlled deployment, which for us is our early access program. And this is you get this out to a couple thousand people who are really excited to give you highly vigilant but useful feedback about how this behaves, not in an open loop, but in a closed loop way in the real world. And you watch their interventions. And we talked about this, like, when somebody takes over, we can actually get that clip, try to understand what happens. And one thing we can really do is we can actually play this back, again, in an open loop way and ask, as we build our software, are we getting closer or further from how humans behave in the real world? And one thing which is super cool with the full self-driving computers, we're actually building our own racks and infrastructure. So we basically can put 4 of our full self-driving computers fully racked up, build these into our own cluster, and actually run this very sophisticated data infrastructure to actually understand over time, as we tune and fix these algorithms, are we getting closer and closer to how humans behave, and ultimately, can we exceed their capabilities? And so once we had this, we felt really good about it. We wanted to do our wide rollout. But to start, we actually asked everybody to confirm the car's behavior via stock confirm. And so we started making lots and lots of predictions about how we should be navigating the highway. We asked people to tell us, is this right or is this wrong? And this is, again, a chance to churn that data engine. And we did spot some really tricky and interesting long tails of, in this case, I think a really fun example, like there are these very interesting cases of simultaneous merging where you start going and then somebody moves either behind or before you, not noticing you. And what is the appropriate behavior here? And what are the tunings of the neural network we need to do to be super precise about the appropriate behaviors here? We tuned these in the background, we made them better. And over the course of time, we got 9 million successfully accepted lane changes. And we use these, again, with our continuous integration infrastructure to actually understand, do we think we're ready? And this is one thing where full self-driving is also really exciting to me, since we own the entire software stack, straight from the kernel patching all the way to the tuning on the image signal processor. We can start to collect even more data that is even more accurate, and this allows us to do even better and better tuning, these faster iteration cycles.
I'm going to break that down for you. That is a ton of data that they're collecting in that short time frame. But it's not just the quantity of that data, it's the quality.
Earlier this month, we're ready to deploy an even more seamless version of Navigate on Autopilot on the highway system. And that seamless version does not require a stock confirm. So you can sit there, relax, put your hand on the wheel, and just oversee what the car is doing. And in this case, we're actually seeing over 100,000 automated lane changes every single day on the highway system. And this is something that's just like super cool to us to deploy at scale. And the thing that I'm kind of most excited about from all this is the actual life cycle of this and how we actually are able to turn that data engine crank faster and faster and faster with time. And I think one thing that's really becoming very clear is the combination of the infrastructure we have built, the tooling we built on top of that, and the combined power of the full self-driving computer. I believe we can do this even faster as we move Navigate on Autopilot from the highway system onto city streets.
You're damn right. Fast forward to the present, we know this to be true. The sophistication of FSD Beta and Autopilot merging together, oh yeah, we're not done yet, folks.
To the best of my knowledge, all those lane changes have occurred with 0 accidents.
That is correct, yeah. I watch every single accident. So,
yeah. So it's conservative, obviously. But it's to have hundreds of thousands going to millions of lane changes and 0 accidents is, I think, a great achievement by the Tesla team. Yeah.
Thank you.
Concur.
A few other things that are maybe worth mentioning. In order to have a self-driving car or robotaxi, you really need redundancy throughout the vehicle at the hardware level. Starting in, I believe it was October 2016, all cars made by Tesla have redundant power steering. So we have redundant motors on the power steering. So any one failure of if the motor fails, the car can still steer. All of the power and data lines have redundancy. So you can sever any given power line or any data line, and the car will keep driving. Auxiliary power system, even if the main pack, you lose complete power in the main pack, the car is capable of steering and braking using the auxiliary power system. So you can completely lose the main pack, and the car is safe.
Safety first, ladies and gentlemen. Safety first.
The whole system, from a hardware standpoint, has been designed to be a robotaxi since basically October 2016. We do not expect to upgrade cars made before that. Unless it's designed in, it's not worth it. So we've gone through the future of self-driving, where it's clear it's hardware, it's vision, and then there's a lot of software, and there's the software problem here should not be minimized. It's a massive software problem, managing vast amounts of data, training against the data. How do you control the car based on the vision? It's a very difficult software problem. Going over just like Tesla master plan. Obviously, we've made a bunch of forward-looking statements, as they call it. But let's go through some of our other forward-looking statements that we've made. Way back when we created the company, we said we'd build the Tesla Roadster. They said it was impossible, and that even if we did build it, nobody would buy it. Universal opinion was that building an electric car was extremely dumb and would fail. I agreed with them that probability of failure was high, but that this was important. So we built the Tesla Roadster, got it into production in 2008, and shipping that car. It's now a collector's item. So we'd build a more affordable car with the Model S. We did that. Again, we were told that's impossible. I was called a fraud and a liar, and it was not going to happen. This is all untrue. Okay, famous last words. Now we went into production with the Model S in 2012. It exceeded all expectations. There is still, in 2019, no car that can compete with the Model S of 2012.
Your mother, right. How can you doubt us? I mean, back then it made sense, but it's like, now what?
Still waiting. So we'd build an affordable car, maybe highly affordable. It's affordable, more affordable, with the Model 3. We built the Model 3. We're in production. Said we'd get over 5,000 cars a week for Model 3. At this point, 5,000 cars a week is a walk in the park for us. It's not even hard. So we'd do large-scale solar, which we did through the SolarCity acquisition, and that we'd develop and deploy the solar roof, which is going really well. We're now on version 3 of the solar tile roof. I have it on my house, and it's great. I said we'd make the power wall and the power pack, and we made the power wall and power pack. In fact, the power pack is now deployed in massive grid-scale utility systems around the world, including the largest operating battery projects in the world that at above 100 megawatts. All these things, I said we would do them. We did it. I said we'd do it. We did it. We're going to do the robotaxi thing too. Only criticism, and it's a fair one, and sometimes I'm not on time.
Sometimes. But let's cut them a little slack. This problem is gigantic, and no one's ever done it before.
I get it done, and the Tesla team gets it done. What we're going to do this year is we're going to reach combined production of 10,000 a week between SX and 3. Feel very confident about that. And we feel very confident about being feature complete with self-driving. Next year, we'll expand the product line with Model Y and Semi, and we expect to have the first operating robotaxis next year.
Yeah, that obviously hasn't occurred, and truth be told, I don't have that happening until about this time next year. But with their continuing data flywheel, it's only a matter of time. If it's in 6 weeks, 3 months, or 3 years, the end result is still the same. A multi-trillion-dollar opportunity is at hand. I think some of you are starting to speak fluent cash register.
It's always difficult to, like, when things are on an exponential at an exponential rate of improvement, it's very difficult to kind of wrap one's mind around it because we're used to extrapolating on a linear basis. So any customer will be able to add or remove their car to the Tesla network. So we expect this to operate it's sort of like a combination of maybe the Uber and Airbnb model. So if you own the car, you can add or subtract it to the Tesla network, and Tesla would take 25 or 30% of the revenue. And then in places where there aren't enough people sharing their cars, we would just have dedicated Tesla vehicles. When you use the car, we'll show you our ride-sharing app. So you'll be able to summon the car from the parking lot, get in, and go for a drive. Potential for smoothing out the demand distribution curve, and having the car operate at a much higher utility than a normal car would operate. So, like, typically the use of a car is about 10 to 12 hours a week. So most people will drive 1.5 to 2 hours a day, typically 10 to 12 hours a week of total driving. But if you have a car that can operate autonomously, then most likely you'd have that car operate for a third of the week or longer. So the fundamental utility of a vehicle increases by a factor of 5. So you can look at this from a macroeconomic standpoint and say, just if this was like if we were operating some big simulation, if you could upgrade your simulation to increase the utility of cars by a factor of 5, that would be a massive increase in the economic efficiency of the simulation. Just gigantic. We'll do Model 3, S3 and X as taxis, but we made an important change to our leases. So if you lease a Model 3, you don't have the option of buying it at the end of the lease. We want them back.
Yes, indeed. No option to buy. We'll take that car back, please, and thank you.
So the current cost of a Model 3 robotaxi is less than $38,000. We expect that number to improve over time. And we're designing the cars. The cars currently being built are all designed for 1 million miles of operation. So the drive units are designed and tested and validated for 1 million miles of operation. The current battery pack is about maybe 300 to 500,000 miles. The new battery pack that's probably going into production next year is designed explicitly for 1 million miles of operation, really optimizing the car for a hyper-efficient robotaxi. And at some point, you won't need steering wheels or pedals, and we'll just delete those. These things become less and less important. We'll just delete parts. They won't be there. Years from now, we make a car that has no steering wheels or pedals. And if we need to accelerate that time, we can always just delete parts. Easy.
Now, this is a big sticking point for Elon Musk if you've read his book back there. Steering wheels and pedals, he does not want them on the car.
Say long term, 3 years, robotaxis with eliminated parts, maybe it ends up being $25,000 or less. Electricity consumption is very low. So we're currently at 4.5 miles per kilowatt hour, but we'll improve that to 5 and beyond. And there's just really no company that has the full stack integration. We've got the vehicle design and manufacturing, we've got the computer hardware in-house, we've got the in-house software development and AI, and we've got by far the biggest fleet. It's extremely difficult, not impossible perhaps, but extremely difficult to catch up when Tesla has 100 times more miles per day than everyone else combined.
Don't be modest, Elon. This shit is impossible for any other company to catch up.
These days, this is the cost of running a gasoline car, or the average cost of running a car in the U.S. This is taken from AAA. So it's currently about 62 cents a mile, 13,500 miles, 250 million vehicles, adds up to $2 trillion a year. The cost of ride sharing is, according to Uber and Lyft, is $2 to $3 a mile. The cost to run a robotaxi, we think, less than 18 cents a mile. If you say, what would be the probable gross profit from a single robotaxi? We think probably something on the order of $30,000 per year.
These numbers are conservative, folks. Yeah.
So in nominal dollars, that would be, a little over $300,000 over the course of 11 years. It might be higher. I think these consumptions are actually relatively conservative. And this assumes that 50% of the miles driven are not useful. So this is only at 50% utility. By the middle of next year, we'll have over 1 million Tesla cars on the road with full self-driving hardware, feature complete, at a reliability level that we would consider that no one needs to pay attention. Meaning you could go to sleep from our standpoint, if you fast forward a year, just a little, maybe a year and 3 months, but next year for sure, we will have over 1 million robotaxis on the road.
That didn't happen.
The fleet wakes up with an over-the-air update. That's all it takes.
But that is true. This will become reality. It's not a matter of if, only when.
You say, what is net present value of a robotaxi? Probably on the order of a couple $100,000. So buying a Model 3 is a good deal. Our own fleet, I don't know, I guess long term we have probably on the order of 10 million vehicles. If you look at our compound annual production rate since 2012, which is like that's our first full year of Model S production, we went from 23,000 vehicles produced in 2013 to around 250,000 vehicles produced last year. So in the course of 5 years, we increased output by a factor of 10. I would expect that something similar occurs over the next 5 or 6 years.
So in terms of one thing is the snake charger, I'm curious about that. And also, how did you determine the pricing? It looks like you're undercutting the average Lyft or Uber ride by about 50%. So I'm curious if you could talk a little bit about the pricing strategy.
Solving for the snake charger is pretty straightforward. It's from a vision standpoint. It's like a known situation. Any kind of known situation with vision is like a charge port. It's trivial. So yeah, the cars would just automatically park and automatically plug in. There would be no human supervision required. Pricing, we just threw some numbers on there. I mean, I think definitely plug in whatever pricing you think makes sense. We just kind of randomly said, okay, maybe $1. There's on the order of 2 billion cars and trucks in the world. So robotaxis will be in extremely high demand for a very long time. My observation thus far is that the auto industry is very slow to adapt. I mean, like I said, there's still not a car on the road that you can buy today that is as good as the Model S was in 2012. Actually, not enough appreciation for the difficulty of manufacturing. Manufacturing is insanely difficult. A lot of people I talk to think if you just have the right design, you can instantly make as much of that thing as the world wants. This is not true. I mean, Audi's having major problems manufacturing e-tron, and they're extremely good at manufacturing. And if they're having problems, what about others?
In case you don't know the end of the movie, folks, they're struggling as well and will continue to struggle, especially if you're going to use Tesla as their success metric. Game over, folks.
There's on the order of 2 billion cars and trucks in the world, on the order of about 100 million units per year of production capacity of vehicles, but only of the old design. It will take a very long time to convert all of that to full self-driving cars. And they really need to be electric because the cost of operation of a gasoline diesel car is much higher than an electric car. So any robotaxi that isn't electric will absolutely not be competitive.
I have a question. If I'm Uber, why wouldn't I just buy all your cars? Why would I let you put me out of business?
There's a clause that we put into our cars, I think it was about 3 or 4 years ago. They can only be used in the Tesla network.
Even a private person, like if I go out and buy 10 Model 3s, I can run it on the network. That's a business now, right?
You're only allowed to use the Tesla network.
Right, but if I use the Tesla network, in theory, I could run a car-sharing robotaxi business with my 10 Model 3s.
Yes, but it's like the App Store. You can only add or remove them through the Tesla network, and then Tesla gets a revenue share.
But similar to Airbnb, though, in that I have this home, my car, and now I can just rent them out. So I can make an extra income from owning multiple cars and just renting them out. Like I have a Model 3, I aspire to get this Roadster here next when you build it, and I'm going to just rent my Model 3 out. Why would I give it back to you, you know?
I guess you could operate a rental car fleet, but I think this is very unwieldy. Yeah.
I don't know. Seems easy.
Okay. Try it.
The strategy we've heard from other players in the robotaxi space is to select a certain municipal area to create a geo-fenced self-driving. That way you're using an HD map to have a more confined area with a bit more safety. We didn't hear much today around the importance of HD maps. To what extent is an HD map necessary for you? And second, we also didn't hear much about deploying this into specific municipalities where you're working with the municipality to get the buy-in from them, and you're also getting a more defined area. So what's the importance of HD maps, and to what extent are you looking at specific municipalities for rollout?
I think HD maps are a mistake. We actually had HD maps for a while. Actually canned that. Because you either need HD maps, in which case, if anything changes about the environment, the car will break down. Or you don't need HD maps, in which case, why are you wasting your time doing HD maps?
Damn! Your mother f***ing right.
Two main crutches that should not be used and will, in retrospect, be obviously false and foolish are LiDAR and HD maps. Mark my words.
Curious where we are today in terms of full self-driving attach rates, in terms of the financial implications. I think it's hugely beneficial if those attach rates materially increase because of the higher gross margin dollar that flow through to the extent people do sign up for full FSD. Just curious how you see that ramping, or what the attach rates are today versus, you know, how do you expect to educate consumers and get them aware that they should be attaching FSD to their vehicle purchases?
We're going to ramp that up massively after today. I mean, the fundamental message that consumers should be taking today is that it's financially insane to buy anything other than a Tesla.
Ding, 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 ding! Tell him what he's won, Johnny! I've been preaching this to anybody that will listen to me. And at these dirt cheap rates, FSD has also dropped $3,000. You'd have to be insane not to want to purchase a Tesla. But alas, some people just don't speak the language.
It'll be like owning a horse in 3 years. I mean, fine if you want to own a horse, but you should go into it with that expectation. If you buy a car that does not have the hardware necessary for full self-driving, it is like buying a horse. And the only car that has the hardware necessary for full self-driving is a Tesla. Like, people should really think about their purchase. Any other vehicle. It's basically crazy to buy any other car than a Tesla. We need to convey that argument clearly, and we will after today.
I'm doing the best I can, Elon. I'm doing the best I can.
A neural net architecture question. Do you use different models for, say, path planning and perception, or different types of AI, and sort of how do you split up that problem across the different pieces of autonomy?
Right now, AI or neural nets are used really for object recognition, and we're still basically just using it as still frames, so identifying objects in still frames and tying it together in a perception path planning layer thereafter. But what's happening is that the neural net is kind of eating into the software base more and more. And so over time, we expect the neural net to do more and more. Now from a computational cost standpoint, there are some things that are very simple for a heuristic and very difficult for a neural net. And so it probably makes sense to maintain some level of heuristics in the system because they're just computationally 1,000 times easier than a neural net. Like a neural net is like a cruise missile. And if you're trying to swat a fly, just use a fly swatter, not a cruise missile. But over time, I would expect that it moves really to just training it against video, and then if video in, car steering and pedals out. Or basically video in, lateral and longitudinal acceleration out, almost entirely. That's what we're going to use the Dojo system for. There's no system that can currently do that.
Just going back to the sensor suite discussion, Elon, one area I'd like to just talk about is a lack of side radars. In a situation where you have an intersection with a stop sign where there's maybe a 35, 40 mile per hour cross traffic, are you comfortable with the sensor suite, the side cameras being able to handle that? Just maybe talk a little bit about that.
Yeah, no problem. I mean, essentially the car is going to do kind of what a human would do. And you can think of a human as like basically a camera on a slow gimbal. And it's quite remarkable that people are able to drive the car in the way that they are, because if you can't look in all directions at once. The car can literally look in all directions at once with multiple cameras. So humans are able to drive just by sort of looking this way, looking that way. They're actually stuck in their driver's seat. They can't really get out of the driver's seat. So it's like kind of one camera on a gimbal, and is able to drive. A conscientious driver can drive with very high safety. The cameras in the cars have a better vantage point than the person. So they're like up in the B pillar or in front of the rearview mirror. They've really got a great vantage point. So if you're turning onto a road that's got a lot of high-speed traffic, you can just do what a person does, just like turn a little bit, don't go fully into the road, let the camera see what's going on, and if things look good, and then the rear cameras don't show any oncoming traffic, off you go. And if it looks sketchy, you can just pull back a little bit, just like a person. The behavior is like it starts to become remarkably lifelike.
Your mother f***ing right. Just like a person, and that's what the neural nets. Video in, vehicle controls out. It's about to get real nice for FSD.
Questions on safety. What data can you share with us today of how safe this technology is, which would obviously be important in a regulatory or insurance discussion?
Well, we publish the accidents per mile every quarter, and what we see right now is that autopilot is about twice as safe as a normal driver on average, and we expect that to increase quite a bit over time. Like I said, in the future, it will be consumers will want to outlaw. I'm not saying they will succeed, nor am I saying I agree with this position, but in the future, consumers will want to outlaw people driving their own cars.
Now, I'm for people doing whatever they want, as long as it doesn't harm themselves or others. Unfortunately, with 45,000 deaths on highways, this is no longer about what you want. Much like the seatbelt, this will become standard practice here in the United States, whether we want it or not.
Think of like elevators. Elevators used to be operated on a big lever, like you go up and down the floor, and there's like a big relay, and you had elevator operators, but then periodically they would get tired or drunk or something, and then they'd turn the lever at the wrong time and sever somebody in half. So now you do not have elevator operators. And it would be quite alarming if you went into an elevator that had a big lever that could just move between floors arbitrarily. So there's just buttons. And in the long term, again, not a value judgment, I'm not saying I want the world to be this way. I'm saying consumers will most likely demand that the people are not allowed to drive cars.
And Elon, a follow-up. Can you share with us how much Tesla is spending on autopilot or autonomous technology by order of magnitude on an annual basis? Thank you.
It's basically our entire expense structure.
Everything. This is the only thing that matters. Everything around our business focuses on this technology. And there you have it, Tesla's first autonomy day. Investors and analysts alike were able to ask plenty of questions about what was presented that day. Now, although some of the timelines are off, Tesla's progression toward artificial general intelligence cannot be refuted. And let's not forget that Tesla has millions of cars on the road with the flip of the switch could be added to their robotaxi fleet. Now I know this is all conjecture. That is, until it becomes fact. Easy there, cash register, I'm getting there. The opportunity lies in investment during conjecture before fact occurs. I've experienced the technology firsthand. It is not perfect. And 2 years ago, I'd say that it wasn't even better than me. But now, I know it's a better driver than I am, despite the casual intervention here and there. But the rate of progress is phenomenal. So much so that I know that this technology will be complete. But damned if I know what the timeline is. I'm just going to invest as much money as I can before it ceases to be conjecture and turns into fact. But you do you. That's all I got for you today. Class is over on Tesla's first autonomy day. Office hours are still in the comments. Be easy. Peace.